Chapter 5, Section 5, Standard Form. Standard form is the third way to write an equation of a line. Remember, so far we've talked about slope-intercept form, which was y equals mx plus b. We've also talked about point-slope form, which was y minus y1 equals m, the slope, in parentheses x minus x sub 1. Remember I said that there were going to be three ways to write an equation for a line, and this is the third way. Standard form is ax plus by equals c. A and b are both cannot both be 0 at the same time. So a could be 0 or b could be 0, but a and b can't be 0 at the same time. This form is going to allow us to find the x and the y intercepts very easily. To find the y-intercept, we are going to plug in 0 for x, and then to find the x-intercept, we're going to plug in 0 for y. Remember, the y-intercept is going to be the point where the line crosses the y-axis, and then the x-intercept is going to be the point where the line crosses the x-axis. This first example says, what are the x and y intercepts of 2x plus 6y equals 18? To find the y-intercept first, I'm going to plug in 0 for x, so I have 2 times 0 plus 6y equals 18. Well, 2 times 0 is 0, so I'm left with just 6y equals 18. To solve for y, I need to divide by 6 on both sides, and when I do so, I find that y equals 3. So my y-intercept is a point at 0, 3. To find my x-intercept, I'm going to plug in 0 for y. So I have 2x plus 6 times 0 equals 18. When you multiply 6 times 0 is just 0, so you're left with 2x equals 18. To solve for x, we need to divide by 2 on both sides, and when you do so, you find that x equals 9. So the x-intercept of the line with an equation of 2x plus 6y equals 18 would be at 9, 0. This example says, what is the graph of 4x minus 3y equals 12? To graph an equation when we're given standard form, we're going to find the y-intercept and the x-intercept. We're going to plot them in the coordinate plane, and we're going to connect the two intercepts. So to find the y-intercept, remember we plug in 0 for x, so we have 4 times 0 minus 3y equals 12. 4 times 0 is 0, so you're left with negative 3y equals 12. When you divide both sides by negative 3, you get y equals negative 4. So your y-intercept is the point at 0, negative 4. To find the x-intercept, I plug in 0 for y. So we have 4x minus 3 times 0 equals 12. 3 times 0 is 0, so we're left with 4x equals 12. To solve for x, we need to divide by 4 on both sides, and when we do so, we find that x equals 3. So the x-intercept is going to be a point at 3, 0. To graph this line, I'm now going to plot my two intercepts. Remember, I have an intercept at 3, 0, and then another intercept at 0, negative 4. And now I'm simply going to draw a line through those 2 points. So this is the graph of the equation 4x minus 3y equals 12. The next example says, what is the graph of each equation? A is x equals negative 1. If you know that x equals negative 1, you know that the x-intercept is going to be negative 1. Notice in this equation, though, there is no y. When there is no y in the equation given, you are going to have a vertical line through the x-intercept. So in this case, if x equals negative 1, I'm going to have a vertical line through negative 1 on the x-axis. It's going to be the same idea for b, which says y equals 4. If y equals 4, then that means that the y-intercept is 4. If there is no x, that means that it is not going to cross the x-axis. So in this case, if y equals 4, I'm going to have a horizontal line through 4 on the y-axis. Any vertical line is going to have an equation of x equals a number. Any horizontal line is going to have an equation of y equals a number. This example says, what is y equals negative 3/5 x plus 4 in the standard form using integers? If you think about standard form, we know that in standard form, my two variables need to be on the same side of the equation. And it asks me to use integers. Let's review what an integer is really quickly. Remember, an integer is a positive or negative whole number. So we don't want any fractions or decimals in my equation. The first step, though, I need to do is to get x and y on one side by themselves. In order to do that, I need to add 3/5 x to both sides of this equation. The reason why I'm adding 3/5 x is because I have to do the inverse or the opposite of a negative 3/5 x. The opposite of a negative 3/5 x is adding a positive 3/5 x. When you add 3/5 x to both sides, you're left with 3/5 x plus y equals 4. We can't combine my x and my y because they are not like terms. This is now getting close to being in standard form, but we have to use integers. In order to use integers, I need to get rid of the 3/5. I need to get rid of the denominator of 5. In order to get rid of a denominator of 5, I need to multiply by the whole number 5. But I can't just multiply one piece of an equation by a number. I have to multiply the entire equation by a number. So I need to multiply by 5 on the left side and the right side of the equation. And on the left side, I need to distribute the 5. So I need to do 3/5 x times 5 plus 5 times y. Well, 3/5 x times 5 is just 3x plus 5 times y is 5y. And on the other side, when you multiply 4 times 5, you get 20. So y equals negative 3/5 x plus 4, written in standard form, gives you the equation 3x plus 5y equals 20. Both of these equations, the one that was given to me was in slope-intercept form, and then this equation that I've written in standard form, both of these equations are going to graph the exact same line. So it's just two different equations that represent the same line. And actually, if I wanted to, I could also write an equation for this same line in point-slope form, but we're not going to do that today. The last example says a festival sells ride tickets for 50 cents each and game tickets for 20 cents each. You have $5 to spend on tickets at the festival. Write and graph an equation that describes the items you can purchase. What are 3 combinations of game and ride tickets you can purchase? The first thing I need to do is go ahead and write an equation. We are talking about standard form. I am going to write an equation that is in standard form. This equation that I'm going to write, and you can actually write it differently if you would like to, but the way that I'm going to write it is I'm going to say 0.5x plus 0.2y equals 5. 0.5 times x would represent the 50 cents per ride, plus the 0.2 times y would represent the 20 cents for the game ticket, and I've set it equal to 5 because I have $5 to spend. So in this equation that I wrote, x is going to represent the number of rides, and y is going to represent the number of game tickets that I can buy. To graph this equation, because I did write it in standard form, I'm going to go ahead and I'm going to find the y-intercept and the x-intercept. To find the y-intercept, I'm going to plug in 0 for x. When I do 0.5 times 0, I get 0. So I have decimal 2y equals 5. When I divide both sides by decimal 2, I find that y equals 25, or the y-intercept is at 0, 25. To find the x-intercept, I'm going to plug in 0 for y. When I multiply by 0, remember it's 0, so I'm left with decimal 5, x equals 5. When I solve for x, I find that x equals 10. So my x-intercept is going to be at 10, 0. Notice these, when y equals 25, that's going to tell me that I can buy 25 game tickets. And notice for the x-intercept, when x equals 10, that tells me that I could buy 10 ride tickets. Notice that each of those is when I'm buying none of the other type of ticket. I'm going to go ahead and plot my points on the coordinate plane that I've graphed. That's a very rough sketch. If you had graph paper, you could make a much better graph. The last thing that they asked me to do says, what are 3 combinations of game and ride tickets you can purchase? There are several different combinations that you could use. I've already actually found 2 different combinations of ride tickets and game tickets that I could purchase with my y and my x-intercept. Remember, y is the number of games and x is the number of rides that you can purchase. So just from the 2 intercepts that I've found, I can say you could play 25 games, because remember, y is representing the number of games. You could ride 10 rides. Notice that each of those is without playing or riding the other games or rides. Then I need to find a third combination. To find a third combination, you can choose whatever number you would like to plug in. Now remember, I will tell you, you cannot ride half a ride, and you cannot play a part of a game. So whatever you choose to plug in, you need to get both numbers to be whole numbers. That's the only thing that you could make a mistake here on, is that to remember, if you only have 10 cents left, you're not going to be able to play half a game. You're not going to be able to do anything with that 10 cents. And we want to spend all of our $5. So I'm going to go ahead, and I chose to plug in 4 for y. When I plug in 4 for y, I get 4 for x. When I plug in 4 for x, that means that I would be riding 4 rides. When I plug in 4 for x, 0.5 times 4 is 2, plus decimal 2y equals 5. When you solve for y here, you would find that y equals 15. Which means that you could ride 4 rides and play 15 games. That would be a third combination. You don't have to choose to use 4 for x and 15 for y. There are several other combinations that you could use. You could have plugged in 2 for x. I would choose an even number for the number of rides, though, because they are 50 cents each. If you chose an odd number of rides, you would be left spending 50 cents. And when you look at how much each game ticket is worth, it's 20 cents each. So there's no way to make up for that 50 cents with the game tickets. Today's assignment is on page 353. It's numbers 1 through 34.